Alright, welcome back to today's ColoVision on how to conclude the spectrum lab. So at this time what you should have are a bunch of lines on paper like this where you went and recorded the colors. Here's a sample of kind of what a data table should look like right now. Anyway, we can see colors recorded on here all over the place. We've got a list of names of what each one of these bulbs were written over here. Now, how are we going to attach this in our lab book, first of all, before we even get any further? Here's what I want you to do in your lab book. I want you to take a page in your lab book, strike the entire page like this, put your initials and dates, and then take the paper that you've got, fold that paper over. So I'm going to fold that piece of paper in half, and what I'm going to do is I'm just going to take and staple it like this is on page 11. I've got a staple here, and I've got a staple. So I'm just going to staple it into the lab book, and then I should be able to fold it over and then close it up into my lab book. So that's the way I'm going to attach the data table into the lab book. So now let's go over what we want for a conclusion in this lab. So your data table is going to be stapled into your lab book. Your conclusion, I want to know three things in the conclusion. One, what was the unknown element? That spectrum of your unknown should have matched one of your other 8, 9, or 10 spectrums that you have. Number two, tell me the difference between fluorescent light bulbs and incandescent light bulbs. You've seen the difference. By the way, keywords I'm looking at on this difference between those two light bulbs. I'm looking for you to use words like continuous. Wow, I'm not sure I can spell continuous right. How do you spell the word continuous? C-O-N. Yep. U-O-U-S. So, continuous. Oh, that looks much better. Hopefully I won't get trashed on YouTube for my lack of spelling, but hey, you come to this channel for stuff with numbers, not with things like that. And now, anyway, let's see what else we can come up with. I want you to see this. I want to see these words. Continuous and line spectrum. Too bad I'm having a horrible time writing this stuff down. One of these had a continuous spectrum, which meant it was all the colors. The other one was a line spectrum. A line spectrum, this is an example of a line spectrum where all you see are specific colors written out like this. All right, now for the last and the biggest things. I want to have four energies for the 4 different wavelengths of hydrogens. So this is going to be your one big example of calculations that you're going to end up having. All right, so are we ready to do these calculations? So on the back side of a page in your lab book, so let's go to the back side of a page. I'm going to walk you through one, and you're going to have to do, I guess, 3 others. But here's what I want you to have in your lab book. So like if we go back to this one and look, I've got a blue line. It looks like at about 4. That looks like I've got a violet line about 440 nanometers recorded here. I want to find this. I've got another one for me. I've got one at 500. I've got one here. It looks like, I think it was more like 610 is where I had it recorded. And then this one I've got 660. So I want to find an energy for all 4 of these in my lab report. So let's see if we can't do a calculation for this. So I'm going to do a calculation for the first one. So if I have a lambda of 440 nanometers, I want to find the energy to this both in joules and I want to find it in EV. So let's walk through that real quick. First of all, if I want to find energy, I'm going to need 2 things. E is equal to HF, Planck's constant times frequency. And then I'm going to also need to use this equation. C equals lambda F. So I'm going to use this equation first. And we could do a little algebra and combine these, but I'm not going to do that. And I'm going to sit here and do it the long way because you're 11th graders and don't deserve it to be any easier. But anyway, C represents the speed of light. 3 times 10 to the 8 equals lambda, which for me is 440 nanometers. So I'm going to write 440 times 10 to the negative 9 F. And now I'm going to take my calculator, and this is going to give me my frequency. So, turn this thing on, 3, 10 to the 8 divided by 440, 10 to the negative 9. So I've got a frequency of 6.8. Let's go, I'm just going to go 6.8. I didn't have a lot of sig figs. Times 10 to the 14 hertz. So there is my first frequency. All right. So now I'm going to take this frequency and I'm going to plug it into this equation, and I should have my energy. So E would be equal to H is Planck's constant, 6.63 times 10 to the negative 34 times, I know I'm being a bad boy not using units, 6.8 times 10 to the 14 hertz. So 6.63 to the negative 34th times 6.8, 10 to the 14 is 4.5 times 10 to the negative 19 joules. Now, by the way, this could be a great video because I may actually blow up on a class right now. This could be so exciting for YouTube land. I can see the video now. Teacher explodes on group of 11th graders. It's building close. If that door opens one more time and I hear another burst of someone laughing and acting like an idiot, it could very well happen. So let's take this, and now let's do one more conversion. I want to convert that to EVs. 4.5 times 10 to the negative 19 joules. Draw my line, put my X. The conversion factor. There's 1.6 times 10 to the negative 19 joules for every 1 electron volt. So let's do a little conversion. 4.5, 10 to the negative 19. I don't know why I'm putting in 10 to the negative 19. They just cancel out. Divide by 1.6, 10 to the negative 19. The answer is 2.8 EVs. Now, I should have a set of calculations just like this for every wavelength. So if this was my number 1, 440, my next one is going to be 500 for me. So now I would do the exact same set of calculations for 500 nanometers. So I do that. Then for me, I would do another set of these calculations for 610, and then a last set of calculations. And again, yours may not be exactly these. I got these off of a student's. Would be 660. So what I'm going to have in my conclusion, what is the unknown? What is the difference between fluorescent and incandescent bulbs? One of them is continuous. One of them has a line spectrum. Identify that. And last thing, what are the energy of the 4 wavelengths of hydrogen? All right, this was one of the simplest ones we could have studied. So like for me in my conclusion, I've already got 2.8. I don't know what the other energies are. They should start going down after this. So it might be like 2.0 or I don't know. I haven't done the calculations. But they should get smaller and smaller as I go through this list because I'm getting bigger wavelengths means less energy. So what I'm going to do is in my conclusion say, for example, I would say I found the wavelength of 440 nanometers. I found the energy of 440 nanometers to be 2.8 electron volts. And so I would go through my list, something like that in conclusion. For source of error, well, that's going to be up to you. Most of you had a very hard time reading the spectroscopes, and you can think of something along those lines. But anyway, hopefully this is enough to get you started and get this lab finished. Sorry it seems like I'm distracted, but that's because of 27 11th graders. They're driving me nuts. Except for Colby and Jared. They're being very good right now. But anyway, thank y'all and bless y'all.